Hello, today we would like to demonstrate you KPA Automation SoftPLC plus visualization software HMI and SCADA. So let's switch to the software host system and demonstrate how we can do this. So first of all, we would like to open PLC editor and open ready to use PLC project, where you have a possibility to see the structure of the product built in using extended PLC functionality. For instance, we have main program with some instances of sub-routines, so-called user-defined function blocks. So each block has an instance, like header data is an instance of function block header data, and overview data is instance of function block overview data, and so on. So if you go inside, right click open user-defined function block, you may see a little logic inside the function block just to make simulation. And in the same style it is done for all functionality. For example, function blocks to do frequency inverter simulation is visible here. Function block has some internal variables, and bool running is to ensure that PLC is actively calculating some stuff or resetting all data to 0. All these variables tend to be visualized and represented to OPC world. In this particular case, we will start with a little example. We will insert a group called group name, and there we will put some information inside. For instance, we will put my variable and select kind of PLC variable we would like to demonstrate. For example, amplitude. And we would like to do the cyclic update. So automatically data type is selected based on OPC, means you have a variable of real type in PLC, and it is converted to float 32 in terms of OPC UA. Then we compile the project, download the project to the executor. So executor is starting and running. Next step will be to open visualization software, select sample project file for solar plant visualization. Here we have OPC configuration, where we will add our OPC configuration. We may browse it and see that we have Straton PLC with our group name inside and with our variable inside. So to visualize such a variable, we can create a control panel. So kind of widget we will do ourselves. This widget we would like to create based on some existing widgets. So we may use either value indicator or whatever, some graphical objects like rectangle and so on, or we may use visualization library where we'll check, for instance, for tank. I'll put reference to the tank where we have some bindings parameters like the level, actual value, min max value, and some chemistry style sheet if we would like to make a special style of this tank. So we may select here OPC tag and enter values like, for example, 100. Min max, and OPC will leave as it is because we just want to drag and drop it from the configuration. We do not want to type the URL here in the box. The same style we can do for value indication. So bindings are done in a similar way. If we would like to change the style of the indicator, we may use special properties like text, brush, and whatever, or we may use built-in style sheets. For example, we'll use like indicator warning style, so that it will display on yellow background information, for instance, if we will be under some limits. So it's just a basic introduction how we can create UI. I will not store this because I do not want to kill existing visualization. Coming back to the project visualization, here we can define which elements could be used as a screens. For this particular case, it was already done. It is done using add button to screen. Any control panel can be used to do screen visualization. In our particular case, let's check how it is done for the inverter room. So in the inverter room, we have complete screen design with a kind of a toolbar with some generic information about user, about security of user, and generic overview about the application. For instance, we have 3 instances of the inverters with some generic properties inside. So the visualization is done in the following way: that inverter is used as a control panel, and each inverter is again like a control panel. So it's built using hierarchical structure. So once we come to concrete inverter instance, we may go also inside and see that each UI element has bindings to whatever OPC tag. And also having some parameters shown on the right side. This kind of parameters will not be used for visualization. It's a kind of a parameters to be used once you placed UI widget on upper layer widget. So on upper layer widget, we have here bindings where we will put some information about the widget configuration. That means that, for instance, we configure each particular element using kind of a template. For instance, here for linked object, we say we will use a parameter name plus path where OPC information is stored. If you browse inside OPC configuration, you may see that we have commonly like inverter 0 with same set of variables, and inverter 1 is also with same set of variables, and so on. So it makes no sense to specify path to each individual UI element. We put here a path to the root of inverter 1, 2, 3, 4, 5, and then based on the root we select proper tag inside the widget configuration. So that is for reusability in the future projects, like it is done here. So we have two variables for parameterization, like a parent object, and here we specify the parent object. We say that is inverter 0, 1, 2, 3, or 5. That is how we build up a visualization. So we will close all UI elements. We will build a project. So project is built, and then we can start visualization. So now we see visualization we have in our sample project. You may see some screens. We may switch over screens and see how it works. So let's switch to our inventor room, and we may switch the logic off for the inverter to disable simulation, or we may switch it on to enable simulation so the data will be displayed on the screen. In the same style, we can do this for exit. Same style, we can do this for OPC UA client from UI Expert. Just open our test, connect to it. So we have here our group 0 with variable. We can just drag and drop it and see the value inside, and we can see also and configure the same in the same style to switch on and off pump. So we can switch off, and then logic is off in the same style as we do from HMI. Thank you for watching. See you next time. Goodbye.